Hi everyone. Let's take a look at this problem. It's a basic net present value analysis problem. The Confectioner's Corner Incorporated would like to buy a new machine that automatically dips chocolates. The dipping operation is currently done largely by hand. The machine the company is considering cost $100,000. The machine would be usable for 10 years but would require the replacement of several key parts at the end of the 5th year. These parts would cost $7,000, including installation. After 10 years, the machine could be sold for $6,000. The company estimates that the cost to operate the machine will be $6,500 per year, and the present method of dipping chocolates costs $24,000. In addition to reducing costs, the new machine will increase production by 5,500 boxes of chocolates per year. The company realizes a contribution margin of $2.10 per box. An 18% rate of return is required on all. And that should read on all investments. Let me see if I can add that in there. Oh, there it is. It does appear. It's just hidden. Let me see if I can bring that a little bit to life. There we go. Okay. What are the net annual cash inflows that will be provided by the new dipping machine? And then 2, we'll compute the net present value for the machine. And we'll use the incremental cost approach. We'll round all dollars to the whole dollar. All right, now, in the interest of saving time, I've worked this one ahead of a schedule. So let's bring some of these items to light. All right, part 1, first we need to compute the operating cost using the present method. And what we come up with is, with the present method, we come up with $24,000, right? It was given in the problem. And then the operating cost with the new method is the $6,500, just to the left of my mouse. Therefore, we've got an annual savings in operating cost of $17,500. Now, another piece of this problem talks about the increase in annual contribution margin. And if we add that in, we come up with a total net annual cash inflows. Now, this is based on the assumption that there actually is demand for the increased production level, right? If there really was no increase in the demand of the 5,500 boxes of chocolates, then that 11,550 really wouldn't be included in the analysis. But we'll assume that since production can be increased by 5,500 chocolates per year, that we can sell them at and still realize a current contribution margin of $2.10 per unit. Let me show how we calculated that. I'll hit the F2 key. We take the $5,500 times $2.10 per box. Okay, so we compute that in terms of annual contribution margin dollars. We add that to the annual savings of $17,500 above, and we come up with $29,050 of total net annual cash inflows. Okay, now to compute number 2, I'll bring that to life. You could compute this in a number of different ways, and I'll just illustrate the schedule I produced to illustrate how to approach this problem. Okay, so the first thing I'll bring to light is the titles. Okay, let me white this one out just for a second here. Turn that back to white. Okay, so what I'm going to do is lay out the years, the cost of the and lay out the other factors we know. The cost of the machine, the annual cash inflows, the replacements of parts, and then produce a total. All right, so if we go down the side, we've got a number of years we could bring to light, right, from 0 to 10. And the cost of the year now is $100,000. So I'll show that in braces or brackets or as a negative number so that we know that that's an outflow. Now they also tell us at the end of year 10, let me slide to give us a little bit of room, we can sell that equipment for $6,000. Okay, so I'll format like that, and we see the $6,000 is a positive net cash flow we're going to receive. Now, in every year, we've got that annual cash inflow coming. So if I take that and simply copy that down for 10 years, that looks a little bit better. And we've got our $29,000 of net cash inflows showing up everywhere. Okay, then they also say at the end of the 5th year, we've got $7,000 of replacement parts. Okay, I'll format that the same way. And then we can just sum the totals across, and you'll see that all I've done is I'm summing all the way down, right? So I can sum it in one cell and then just copy it down. It's all the same formula. Alright, well, with that information, let's drop in the interest rate. And they tell us above, let me slide up, that an 18% rate of return is required on all investments. So we'll drop the 18% in, and then we compute the net present value. And I've done that ahead of time, but let me hit the F2 and show you how we've done this. You take the net present value. In fact, why don't I just redo this so we can watch it. Equal NPV, hit the left parentheses, and then it'll ask for items. Now I'm going to slide up to the formula bar so I get a little screen that you can see. Okay, the rate is the 18%, so bring that down. And then the value 1, rather than putting those in individually, I will just highlight from, look where I start, at year 1 through the year 2. Okay, and then from there, that gives me one formula, but then I need to add to that the outflow in year 0. Okay, now, why did I exclude that in our range in here, this section in here? Because remember that the net present value formula operates as if the cash flows appear at the end of every period. And in this case, the cost of the machine occurs at the beginning of the first period, or period 0. So we need to add that negative amount in outside of the NPV formula in order to correctly value the cost of equipment. Okay, and we come up with rounded dollars of 28,640. Now, you could get numbers not exactly equal to that, but differently or different than that if you used other methods like a financial calculator or present value tables, present value of an annuity tables. But using Excel, the answer that we come up with is 28,640, and I'll bold that because that is the correct answer. I'll also bold that one there because that's the answer to part 1, and that's this problem, everyone. Thank you.